Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing illustrative math, grade 8, unit 4, lesson number 9, practice problems. Our first question here says cell phone plan A costs $70 a month and comes with a free $500 phone. Cell phone plan B costs $50 a month but does not come with a phone. If you buy the $500 phone and choose plan B, how many months is it until your cost is the same as plan A? So what are we going to do? Plan A is $70 a month and comes with a free $500 phone. So that one is just the cost is 70x. 70 times the number of months we've had the plan. The other one, the cost is $50 a month, 50x, plus 500. So, how many months is it until your cost is the same? What are we going to do here? Well, my thought is, if we want the cost the same, one cost equals this, the other cost equals this. How do we figure out when two things are the same? Well, the same means they're equal to each other. 70x equals 50x plus 500. Now, we've got an equation. We've got x's on each side, but we know how to deal with that. Looks like we've got just x's on the left, but we've got x's and numbers on the right. So we've got to get rid of the x's on the right. How do we get rid of 50x? We subtract them. Do it to one side, do it to the other. Those will cancel. 70x subtract 50x. 70 take away 50 is 20. Equals 500. Now what have we got to do? Well, to get x by itself, we got to get rid of multiplying by 20. To undo multiplying by 20, we divide by 20. Do it to one side, do it to the other. X equals 500 divided by 20, which is 5 20s and 100, 25. How many months until your cost is the same? 25 months. Spell better, Mr. Boskin. Okay. What have we got next? Priya and Han are biking in the same direction on the same path. Han is riding at a constant speed of 16 miles per hour. Write an expression that shows how many miles Han has gone after T hours. Y, how far he's gone, equals 16t, because it's 16 miles per hour, unit rate of 16. Priya started riding half an hour before Han. If Han has been riding for t hours, how long has Priya been riding? Priya has been riding t hours plus half an hour. Priya is riding at a constant speed of 12 miles per hour. Write an expression that shows how many miles Priya has gone after Han has been riding for t hours. So, the way this has to work is 12 miles an hour is the unit rate, but Priya's time isn't just t, it's t plus 1/2. So Priya is y equals 12 mile an hour unit rate times her time, which is t, plus 1/2. Okay. Use your expression to find when they meet. Well, when they meet, when they're in the same place, we just have to set the two equations equal to each other. So 16t was Han equals 12 times t plus 1/2. Now let's just solve this equation. Okay, we got space underneath it. 16t equals 12 times the quantity t plus 1/2. Well, we can't do anything to this side yet, but what we can do is distribute over here. 12 times t is just 12t. 12 times 1/2. What's half of 12? I believe that's 6. Now, solving this equation, we got to get all the t's on the same side of the equation. Looks to me like the right side of the equation here is the one with too many different kinds of stuff. So let's get rid of the t's from over there. Take away 12t from that side. We got to do it to the other side. 16t subtract 12t is 4t equals... Hey, 12 times 1/2 is positive 6. Silly goose. Equals 6. Now, what's stopping the t from being by itself? That 4. How do we get rid of the multiplying by 4? We divide by 4. Those will cancel. T equals 6 over 4. Those are both even, which would be 3 over 2, which is 1.5. Find when they meet. They meet in 1.5 hours. Did I say 1.5 hours? In 1.5 hours. Okay, number 3. Which story matches the equation -6 plus 3x equals 2 plus 4x? So we get two big long stories here. Story A is at 5 p.m. the temperature recorded at 2 weather stations in Antarctica are -6 degrees and 2 degrees. The temperature changes at a constant rate, x degrees per hour, throughout the night at both locations. The temperature at the first station, 3 hours after the recording, is the same as the temperature at the second station, 4 hours after the recording. Okay. B says, Elena and Kieran play a card game. Every time they collect a pair of matching cards, they earn X points. At one point in the game, Kieran has -6 points, and Elena has 2 points. After Elena collects 3 pairs, and Kieran collects 4 pairs, they have the same number of points. So, which story matches the equation? Okay, they, I believe, want this one because 5 p.m. temperature at the 2 weather stations are -6 and 2 degrees, -6 and 2. The temperature at the first station, 3 hours, and the second station at 4 hours. Temperature changes at a constant rate of x degrees per hour. Yeah. This one has to be A. Oakley dokley. For what value of x do the expressions 2/3 x plus 2 and 4/3 x subtract 6 have the same value? Same value means they're equal to each other, right? Let's set them equal to each other. 2/3 x plus 2 equals 4/3 x subtract 6. Now, I see more x's on the right side, so let's get rid of them on the left. Subtract 2/3 x. Do it to one side, do it to the other. Left with those cancel, just 2 on that side. 4/3, take away 2/3 is 2/3. Subtract 6. To get rid of the 6, we've got to add 6 to each side. So 8 equals 2/3 x. Now what do we have to do? 2/3 is stopping the x from being by itself. They're being multiplied, so we want to divide by 2/3. Do it to one side, do it to the other. Those will cancel. X equals 8 divided by 2/3. I don't know that off the top of my head, but I know that 8 over 1, dividing by a fraction means multiplying by the reciprocal, would be 8 times 3 is 24, over 1 times 2 is 2. 24 divided by 2 is 12. X equals 12. Okay, decide whether each equation is true for all one or no values of x. Okay, we have 2x on this side. We have negative 3.5x on this side. The number of x's don't match, which means that is true for one value of x. You can solve that equation. Our next one, we have 9 times x is 9x. Subtract 9 times negative 2, negative 18, equals 7x plus 5. The number of x's on each side don't match again, so that is true for 1. Let's just solve it real quick. Subtract 7x, subtract 7x. 9 subtract 7 is 2x minus 18. You were all hoping to hear me sneeze, right? 2x subtract 18 equals 5. Subtract 18 from each side. 2x equals 5. Subtract 18 is negative 13. Divide by 2. Divide by 2. X equals negative 13 halves. Okay, next one. Decide whether it's true for all one or no values. Well, let's distribute again. 3 times 3x is 9x. 3 times 2 is 6. Subtract 2x. Equals 7x plus 6. Combine like terms. 9x subtract 2x is 7x plus 6 equals 7x plus 6. Those look pretty identical to me. Means that is true for all values of x. Okay, what have we got next? Solve each equation. Explain your reasoning, means show your work. Let's distribute. Negative 2 times 5 is negative 10. Negative 2 times negative 3d is positive 6d. 3d plus 16 equals, because we bring everything down. Now, I see more d's on the right, so let's get rid of the d's on the left. Those will cancel. 16 equals negative 10 plus 60 subtract 3d is 3d. Get rid of the 10. To get rid of a negative 10, we add 10. Do it to one side, do it to the other. 26 equals 3d. Divide each side by 3. Those will cancel. D equals 26 divided by 3 is... I don't think that works out nicely. So let's just leave it as 26 thirds. Okay. I'll move this one over so that I don't wind up trying to do it through my head. Now, let's start out by distributing. 2k, negative 3 times 4 is negative 12. Negative 3 times negative k is positive 3k equals 3. I'm writing an x. K plus 4. Combine like terms. 2k plus 3k is 5k minus 12 equals 3k plus 4. More k's on the left, so let's get rid of them on the right. Subtract 3k, do it to the other side. 5k subtract 3k would be 2k minus 12 equals 4. To get rid of subtracting 12, we add 12. Those will cancel. 2k equals 4 plus 12 is 16. Divide by 2, divide by 2. Those will cancel. K equals 16 divided by 2, which is 8. Ooh, this one looks kinda tricky. Kinda tricky indeed. Okay, we have these 9 and 3 on the bottom. I don't much care for those numbers on the bottom. So let's multiply by something that will make them go away. What do we want to multiply by that will make them go away? Well, if I multiply by 9, that multiply by 9 and divide by 9 will cancel right out nicely. Then we are left with just 3y minus 6 on the left. But on the other side, if I multiply by 9, 9 divided by 3, those don't cancel out as nicely. 9 divided by negative 3 is negative 3. So now I need to negative 3 times 4 minus 2y. Now I got some more distributing to do. Negative 3 times 4 is negative 12. Negative 3 times negative 2y is positive 6y. Equals, the other side is still 3y minus 6. More y's on the right, so let's get rid of them on the left. Negative 6 equals negative 12. 6y minus 3y is 3y. To get rid of that 12, we'll add it. Negative 6 plus 12 is positive 6 equals 3y. Divide each side by 3. Those will cancel. Y equals 6 over 3, which is 2. Not even the last one. We've got another problem to do. Describe a rigid transformation that takes polygon A to polygon B. So I want A to go to B. And that looks like a nice rotation. How much are we going to rotate it? 180 degrees. Where are we going to rotate it around? Rotate that 180 degrees around the origin, and A goes to B. Okay, now that's our last problem for today. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.